In the last class, we saw that when we're trying to summarize a data set, it is important to identify and summarize not only the averages, so the measures of location, of central location or central tendency, but also the variability. The variability is an integral part, a very important part of statistical data, and it needs to be measured and identified. So that's what we're going to be focusing on today. Now, last time also we were focusing on measures of location for numerical variables, but let's have a look at how variability can be looked at and analyzed or measured for other kinds of variables. So for instance, for nominal variables, we have seen before that just about the only thing we can do is look at frequencies, proportions, and percentages. Well, these also give us some information about the variability. They tell us which values are possible or show up, and how often, and which ones are more frequent, which ones are less frequent, and so on. So that by itself includes information about the variability. For order variables, we saw that there is something else that tells us how variable the data are, and namely that is the range. So that is the pair consisting of the minimum and the maximum. We know what is the smallest value, what is the biggest value. Now, for numerical variables, the first thing we can do is add something else. Since we're dealing with numbers, we can combine the minimum and maximum by looking at their difference. So the range sometimes is also meant as the difference between the maximum and the minimum. Now, this second interpretation of the range is also used, but it is more of a technical interpretation. And in fact, in most health-related articles, when you're going to see the range, it's always going to be given as the minimum and the maximum. Keep in mind also that if I give you the minimum and the maximum, then you can find their difference. But if I give you their difference, then you cannot find what is the minimum, what is the maximum, unless I give you one of the two. So I just wanted to let you know that this is another interpretation of the word range, but you're not going to find it very often. There is one problem, however, with this measurement of range as a measure of variability, and that is the situation when there are outliers in our data set. So for instance, let's say that this is our data, so each dot represents one observation somewhere on the number line. So notice that this data set consists of a bunch of observations which are very close to each other, but it also includes two very far away data. So it could be a whole bunch of numbers close to, say, 6 or 7 or 8, and then you have a 15 and a 1. And so those two numbers are going obviously to affect the range, because if we're going to compute the range from this data set, that range will reflect the whole difference from the smallest to the biggest. But that's a little bit too much, right? You can tell that most of the data are in fact in the middle clump. So how can we take care of that? Well, one way that people have figured out is instead of using the minimum and the maximum, let's use the other two other measures that we have seen that sort of throw away the extreme outliers. And of course, that's by using the quartiles. So what we can do is we can look at the interquartile range, which is denoted by IQR, and it also can be interpreted in two ways. By interquartile range, we can mean the pair consisting of the first and the third quartile, or we can mean the difference between the third and the first quartile. And as for the range, the more common interpretation and the more common use of the interquartile range is as the pair consisting of Q1 and Q3. Now, this is a better measure, and for instance, if we look at the interquartile range in this case, that would focus on the middle half of the data, right? Going from the first to the third quartile, we're hitting half of the data, and so it focuses on the middle half. So it throws away the outliers, yes, the outliers, and therefore it just adjusts for that. But whether we use the range or the interquartile range, we still have a problem. Both of these measures only use two values. The range uses only the minimum and the maximum and totally ignores everything else and how they're connected to each other and how they're spread. And the interquartile range uses the first and the third quartile, still just two numbers, and everything else is ignored. So is there a way in which we can look at the variability of the data by using all the data? That's what we're going to look at next.